Thank you. My name is Srikanth, work for Dell EMC. And one of the things when we think of an enterprise is some old guy sitting and doing something, but that's not the reality. Enterprises is when enterprises widely adopt some technology, that's when you really know that technology has some legs. It's because once they start getting into it, the money starts flowing in, which gives the opportunity for all of us to grow the technology in the ways that we want. So once things hit that threshold, that's when we see a hockey stick kind of improvement in the way people start adopting technologies, right? Today I'm going to talk about in general why people are interested in streaming in the enterprises, what is it that is getting them there, and what can we do to kind of make that happen in general, right? Those are the things that I'm going to talk about today. So start with, let's talk about why is streaming attractive to the enterprise. So the most important thing is reacting in real time to events that are happening. Some of them are so important that you need to immediately react, right? If you give an advertisement campaign, you need to know in real time how people are using it and whether it is really making an impact for them. You want to know in real time what's going on and change your advertising strategy, for example. There are a lot of things in manufacturing and IoT scenarios, that's more obvious, right? You want to find out the defects as soon as possible. You want to find network intrusions as soon as possible. There are a lot of such real-time use cases. The time to reduce your ability to react, right, as fast as you can react in business world, that's what is attractive to them in terms of streaming. But the most important thing is the proliferation of different infrastructures, right? In the IT industry, that's what is bothering them. Because if you look at it, they build things over time, particularly in the big data processing, because it's such an evolving kind of thing. Everyone was talking about HDFS like 10, 15 years back. Those companies look like dinosaurs today, right? Things change that fast in the industry. But what happens in the process, you tend to accumulate a lot of technologies and it becomes messy to kind of use them. So enterprises are looking for a way to consolidate. And the way to consolidate in our world, in our simple world, is really how can you do batch and real-time processing through existing or newer technologies, which simplifies the whole pipeline much easier for them, makes it much more easy for them to operate on, right? Operational efficiency is very, very important, right? Now, what are the key streaming capabilities? That is the operational part of it, why they want to go there, but what are the key capabilities you get with streaming, right? Treating data continuous and as an infinite thing is something that has not happened before, right? Most of the data store systems, you store the data somewhere and then you are statically issuing a query or doing things like that. But first time we have mechanisms with stream process such as Flink to be able to treat data as continuous and infinite, and more importantly, treat them with exactly one's kind of semantics, right? That's very important. In fact, I'll tell you, there is one company which has completely replaced their billing systems with the streaming technology because they can do exactly one's processing without using a relational database. That's very exciting for them. So people are using for those kind of things, newer enterprise, of course. Right, and that comes from providing accurate results, that comes from the consistency of the data, and more importantly, it also comes from the ability to dynamically adjust to the volume of the data coming in, right? Lot of them, right? If you had traditional old world thinking, you have a relation database Oracle somewhere, and it's not easy to scale them. It's very, very hard to scale them. You have to build your own partitioning and all that, and you have to repartitioning is a hell with them. So dynamically scaling things is also becoming very important in this new world, and how do you adapt to the changing trends for the different business applications, right? And finally, this is very important for real-time streaming, processing the data at the point of ingest. Even though HDFS started with this trend that you put compute near the storage, that has become less and less relevant in the batch area because of the improvements in technologies. But for streaming, or near real-time infrastructure, it's still very important. Why? Because if the ingesting system knows exactly where the data is coming in, placing your compute right there really, really speeds up and makes it even more real-time, right? And even more capable to able to process the data at the rate at which it is coming at you, right? So it becomes relevant back again in the real-time streaming world, as opposed to batch processing world where it has lost its sheen, right? When Hadoop initially started. Now, what are the key requirements that we need to do from streaming systems to make this more enterprise ready or enterprise usable, right? One of the things is the barriers for entry. Any kind of the asynchronous processing or stream processing, whatever you call it, always has this huge barrier of entry because it's much more harder for people to reason it, much more harder to debug your applications, right? But if you make some of the things like, Flink SQL is a classic example. Flink didn't start with a SQL thing, but they now have a SQL kind of thing which makes life much more easier. Today, at least in few presentations, I saw people talking about it much more. And the new features that they've introduced today, even in the MapReduce world, it started becoming only when they added some SQL flavor on top of it. Till that time, the adoption was not that good, right? SQL is powerful. Then, it's in a data world, it's not easy to be successful when you have one single component or one single thing, because people want to do a consolidated view of the story. They want to see how they can use it for different purposes, right? So if you provide a proper streaming storage infrastructure, because every single data system that you have there, whether you're Cassandra or an Oracle database or a Postgres, under the covers it uses a consistent log for lots of its functionality. And today, if you look at the industry, we don't really have a durable, consistent, scalable log storage system out there, right? And because of that, each one of those data store systems build their own log storage under the covers, right? If you really provide a distributed, scalable, consistent, ordering guarantees, all those things provided, log storage, what happens is, then you can build all these things, the middleware on top of it. It becomes much more simpler. It kind of democratizes the data layer much more than what it is today, right? Because they can work on that particular aspect. For example, ingest pops up kind of thing, like a Kafka on top of it, or a time series database, right, on top of it, like InfluxDB, or a search capabilities on top of it, like Elasticsearch. In the absence of this, what is happening is, if you look at it, in the very old days, like 80s and 90s, in the client-server architecture days, you had a relation database and you have storage underneath it. Life was happy for a lot of people. But with the explosion of data, the explosion of applications using it, suddenly there is a plethora of data services that have come on which are custom built for specific purposes. And this has resulted in continuous replication of data or duplication of data all over the place. If you look at a typical system today, you store data in some messaging buffer, and then you pull it into Elasticsearch if you want to search. You pull it into a Cassandra, you pull it into an object store, you pull it into HDFS, and you keep on replicating data over and over again. So this has resulted in a lot of complexity and a lot of over storage of the same data again and again in different places, right? And finally, enterprises look for these features because that is very, very important for them. They're not scrappy. They want to build for long term. Once they adopt, they really stick to it for a long time, very, very long time. So it's very important for us to provide proper, a stable product, security, serviceability, availability, all those kind of abilities have to be supported very well to start with, because they always believe, they have a lot to lose if something goes wrong from their perspective, right? So they're very, very careful in adapting a technology, and once they adopt the technology, they'll be in for long term. That's why they always look for these things, which don't look like very exciting computer science problems, but all the more they're very important for them if you want to be successful in the enterprise world. All right. So I want to look at this view, right? It's kind of, I call it a DVR analogy, which we are all familiar with. That's how I want to explain it. And I want to tell why this is important, right? So in DVR, what happens, the video stream is coming, you can pause, play, and do all that kind of stuff at the point of time. Whereas the old world is like a video library, where you get something, store it, and then you can play it, pause it, do whatever you want to do, right? Then DVR, after it stores, it becomes like a video file, right? So the analogy for data similarly is that data as it is coming in, you want to process it, but at the same time, you want to store the data for long-term processing, and you don't want to see it differently, right? What I mean by that is, if you want to do real-time or batch analytics on top of it, they really want to still see data as a stream, not as a separate thing. In the real-time world, as a stream, like most of the people do today, because of the lack of appropriate products and technology in the space, and they view the batch as your video file kind of analogy, right? What we want to say is that you really need to provide a storage which is more like DVR backed up by the video file thing, so that you can always treat data as streams for both these applications. This is one thing which is lacking today, right? Take, for example, if you have Kafka, most of the people think that it's a temporary store. You put data, then you pull it off very soon, right? That's how it's more like a buffer rather than this DVR technology. But what happens because of that? I'll give you one example. This is one of our customers, like a wind turbine sending data. They send data. The initial point of ingestion of the data is into a Kafka log, and then that data is ETL into HDFS, right? So, and they develop a business model or even a machine intelligence model that runs, because that runs on real time. As the data is coming in, they want to decide which turbines to turn off, or if one of the turbines has a problem, or all those things. That's based on a business model that they have developed and keeps running on this, and then the ETL data into HDFS. But business is always changing. They'll come up with a new model. When they come up with a new model, then they have to test against their old data to ensure that it's working correctly. Then what do they do for that? Because their old data is now in HDFS or some other long-term storage system, they have to write against that and then go read the data, test their model, ensure that it's working well. And once they find out it's all working well, the trouble starts, because your real-time stuff is on top of Kafka, is a completely different reading pattern than your long-term storage is, right? So what do? You have to go through all this custom scripting, all typical operational problems that we're all familiar with, right? But the DVR model that I talked about, or the infinite stream model, where you ingest as a stream and store it as a stream, you read it for batch processing, for real time, same way. This completely changes, right? You're ingesting there, you're doing your business logic on top of it. Let's assume a new logic comes up. You go back and read, because it's the same stream, and validate your model. And once you're caught up and find that it is successful and it's good, it's much more easy for you to replace, because you don't have to change anything else. You just have to drop the first one out and make this the operational one. So that's the power of this DVR model for big data processing. How you can do real-time batch processing. But if you think about all the things that I said before, right? Whether it is consolidation, whether it is storage efficiencies, whether it is processing efficiencies, whether it is single operational model for batch processing or real-time processing, all those things apply to this model very well, right? And this is what is exciting enterprises to get onto this model. And they're looking for that kind of product and sweet spot which can do both the things, where you can do storage like this first, and then you need a write stream processor which can do both batch processing and real-time processing. And thirdly, they want to see other middleware to be built on top of it, right? So that there is a consolidation of the storage instead of randomly storing data all over the place, right? So that's the kind of technology that you're looking for. And then an ideal streaming data platform in their view looks something like this, right? Your data ingested into a stream storage that gets, just like a DVR, put into a scaled out storage like Object Store or NFS or even HDFS, whatever you have. And then they're looking for some way to orchestrate their jobs because that's very, very important. And these days, Kubernetes more or less has won that war. I think we don't have to think twice about it. So they need some kind of an orchestration mechanism because, as I told you, right, to kind of put the right job, if it's a real-time job, putting the job where the data is coming in, because if the streaming storage system knows which partition of the data is on which node, it can place the job also accordingly, right? And then the same storage you can use for other middleware that I talked about. Suppose if you want to build a search thing like an Elasticsearch or Splunk, all those systems, what do? They pull the data out of this and then store it in their own storage system, essentially replicating the data. What we can do, we can store it in one place as a stream and build the indices as it is stored. And then when you issue a query or use something like a Kibana or something to query and find the data, you can do that, right? So there's a new way of looking at the middleware. And if the streaming storage is really scalable and be able to handle all this kind of use cases, is consistent, is available, and all those kind of good properties, then it's possible to build other middleware on top of it, right? And also, for it being a real microservices kind of platform, people are looking for some way to synchronize different distributed processes. Having a zookeeper or something is very heavyweight thing for those purposes. And if you provide that, that's what the state synchronizer says there. It's basically a mechanism for you when separate distributed processes want to synchronize on certain thing, which is where a lot of people use zookeeper these days, right? So ideally, this is what they're looking for, right? A stream processor which can treat both real-time and batch in the same way, like a stream. I showed you why, right? And all these kind of other things to consolidate your infrastructure. And then, of course, a nice way to orchestrate because they want to really efficient. And these days, when you have containers all over the place, they want to be able to orchestrate the containers properly so that you can really get every byte out of that machine and every cycle of CPU out of that machine much more efficiently than you could ever before, right? So that's the kind of thing the enterprises are asking for today. And I'll give you an enterprise case study for that where we did something like this. And I'll show you how it has improved. This is a use case for a company in Japan which makes cars and they believe in moving forward all the time. So it's a connected car use case where the cars is sending data, and when you get the data, they want to find out certain error patterns and kind of report back to the users. First thing. Second thing. They also want to use the same platform for batch processing, for building the models based on the existing data that they already have. And of course, they want to reduce the infrastructure needed and all that. So we proposed a solution. I'll show you this here. And we built it with this. So we built it with two systems. One is based on Kafka and Spark, right? That's the left-hand side. And the other thing is Prevega, which is an open source streaming storage solution. It's an Apache 2.0 licensed streaming storage solution. And Flink, that's what we use on the right side, right? If you look at the left side, so the incoming data is the annotated data, then there's a Spark process which decodes the data, stores it back in Kafka, and then that is ETL down into HDFS. And then again, the same data is pulled into an Elasticsearch cluster, and you run queries on that for if it's a search query, and if it is any kind of analytics they do with Spark processes there. On the right side, we have Prevega. Prevega has this property that you can ingest. It's like the DVR model that I talked about before, right? It just exactly does that. So the data is just the real-time processing like the decoder, works on top of the data. It's cached, that layer. And then it's also stored automatically tiered into something like HDFS. You can use an object store. You can use a filer for it for long-term retention. And then if you mark some of the streams as searchable, if they're really searchable, it also indexes the data as it is ingested in real time, right? And stores the indices also. So they can use the same thing for both for their batch processing and real-time processing. And there is no ETLing the data and running separate process for ETLing and all that. They did this, and they wanted to compare both these technologies. And I'm telling you why this has become important. Not only that, it reduces the number of moving parts, it also increases the consolidation of the infrastructure. But more importantly, now we can do continuous query, which is not continuous search query, which is not possible with Elasticsearch and other things. Like you can sit here, they can say, someone can say, I'll try to query. When the speed on highway I-5 increases more than 40 miles per hour on average, then alert me. They give that query and keep working, and when that happens, they get an alert that it is, and they can pack their bags and go home, right? That kind of continuous query is possible now with this mechanism, with this infrastructure, right? Not only that, what they have observed is the storage capacity needed, because you're not storing at multiple places, not once in Kafka and again in HDFS. The storage capacity is almost 1/3, and they could see for the batch training, it was twice as faster, and for the real-time pipeline, it was almost 10 times faster, right? Compared to using Kafka and Spark. So I think I'm running out of time. In short, what I want to say is that the world is changing, the streaming world is changing. It's not only changing because good process like Flink have come into the fore, but it's also changing because fundamentally we are taking a relook. At least I've seen 3 presentations today, which are based on Kafka, which would have been done much better using Pravega. One by Uber, one is Trade Desk guys. I mean, he's here, so maybe he can, we can talk to him afterwards. So I've seen 3 presentations. So when we want to really change the world, relook at the world, change the world face of analytics, I think time has come for us to reinvent all these things in a consolidated way with a stream processor like Flink. And that's when you can really take this technology for much wider adoption across the board along with enterprises. Thank you.